Hello, this is section 7.5, Applications of Rationals. Part 1, Applications involving proportions. Recall a proportion is an equation of the form one fraction equals another fraction where the denominators are not equal to 0. Example 1. Solve the following equations. Be sure to check for extraneous solutions. Well, there's nothing new here. We're still just going to find the LCD. So in part A, the LCD is 7m plus 14. So I'm going to multiply both sides by that. The m plus 14 cancels on the left. The 7 cancels on the right. So we're left with 7n equals 5n plus 70. Subtract 5n from both sides. We get 2n equal to 70. Divide by 2. And we get n is equal to 35, which does not make the denominator, the LCD equal to 0. So that checks. Part B, z over z minus 84 equals negative 1/5. So the LCD here is 5 times z minus 84. So I'm going to multiply everything by that. The z minus 84 cancels out on the left, and the 5 cancels out on the right. And we're left with 5z equals negative z plus 84. Add z to both sides. We get 6z is equal to 84. Divide by 6, divide by 6. We get z is equal to 14. If I think about plugging that into the LCD, that does not make equal to 0. So this is a solution. Example 2. When pediatricians prescribe acetaminophen to children, they prescribed 5 milliliters of acetaminophen for every 25 pounds of the child's weight. If Zoe weighs 80 pounds, how many milliliters of acetaminophen will her doctors prescribe? So when doing these ratio type problems, you have to determine how you're going to set up your ratio. Well, I'm going to do milliliters of acetaminophen to pounds of the child. So we're given the prescription, which is 5 over 25, and then I want to know how much to give, so x over, and then Zoe weighs 80 pounds, so 80. And then I need to solve this. Instead of multiplying by the LCD here, I'm just going to think of this as get x by itself, so I'm only going to multiply by 80 on both sides. And then we get x is equal to 16. So 16 milliliters is how much Zoe would need. Part 2, applications involving uniform motion. So this is the third time we're seeing these types of problems, so I'm hoping you have the formula down by now. D equals RT, which can be encoded in this triangle, and that you'll be using a table that looks like this. Okay. An airplane can fly 200 miles into a 30-mile-per-hour headwind in the same amount of time it takes to fly 300 miles with a 30-mile-per-hour tailwind. What is the speed of the airplane? Okay, so go ahead and set up my table. So we have DRT, and then we're going into the headwind and tailwind. So we got 200 miles in the headwind. and then we got 300 miles in the tailwind. And what we're told is the wind is 30 miles per hour. So going in the headwind, that means it's against our speed, so it'll be x minus 30. And with the tailwind, that means it's boosting our speed, so it'd be x plus 30. And now t, if I go to my triangle, cover up the t, that's d over r. So d divided by r, so we get 200 over x minus 30 and 300 over x plus 30. Okay, then the key part here is it says same amount of time. So that means the two time values we got have to be the same. So 200 over x minus 30 has to equal 300 over x plus 30. Hoping you see here the LCD is x minus 30, x plus 30. So I'm going to multiply both sides by that. The x minus 30 cancels out on the left, and the x plus 30 cancels out on the right. So then we get 200x plus 6,000 equals 300x minus 9,000. Subtract 200x from both sides. Add 9,000 to both sides. So we get 15,000 equals 100x. Divide by 100. Divide by 100. You get 150 equals x. So the speed of the airplane was 150 miles per hour. Danica can sail her boat 5 miles into a 7-mile-per-hour headwind in the same amount of time she can sail 12 miles with a 7-mile-per-hour tailwind. What is the speed of Danica's boat without a wind? So this is going to be set up exactly the same as the airplane. So DRT, headwind, tailwind. We have 5 miles in the headwind. That's harming our speed. 12 miles in the tailwind, which is boosting our speed. And then time is distance over rate. And again, it does say same amount of time. So the equation we get is 5 over x minus 7 equals 12 over x plus 7. The LCD is x minus 7 times x plus 7. So I'm going to multiply everything by that. The x minus 7 cancels out on the left. The x plus 7 cancels out on the right. We get 5x plus 35 equals 12x minus 36. Subtract 5x from both sides. Add 36 to both sides. Or, sorry, I don't know where I'm getting 36 from. That should be an 84. So I add 84 to both sides. Get 119 equals 7x, divide by 7, divide by 7, and get 17 equals x. So the speed of Danica's boat is 17 miles per hour. Example 5. Jasmine trained for 3 hours on Saturday. She ran 8 miles and then biked 24 miles. Her biking speed is 4 miles per hour faster than her running speed. What is her running speed? So this is a uniform motion problem. We have running, we have biking, and then we have a total this time. So we trained for 3 hours, so our total time is 3. She ran 8 miles, don't know what speed. She biked 24 miles, and that was 4 miles per hour faster, so that's x plus 4. You'll never have a total speed, and if you really want to, our total distance then would be 32. Okay, so t is d over r, so we get 8 over x and 24 over x plus 4. And because we have that total row, our time column gives us our equation. 8 over x plus 24 over x plus 4 equals 3. Our LCD here is x plus 4. So I'm going to multiply everything by that. The left fraction, the x cancels out. The middle fraction, the x plus 4's cancel out. So we're left with 8x plus 32 plus 24x equals 3x squared plus 12x. So this is a quadratic equation this time. So I'm going to use the zero product property. So let's combine like terms first. So we get 32x plus 32 equal to 3x squared plus 12x. And now get everything on one side. 0 equals 3x squared minus 20x minus 32. There is no GCF, so I'm going to factor this. I'm going to use the asterisk method. Get negative 96, negative 20, and 3x and 3x. Now, what two numbers multiply to negative 96 and add up to negative 20? That's negative 24 and 4. And this can reduce to x over negative 8. So we get 0 equals x minus 8, 3x plus 4. So that means x minus 8 equals 0, or 3x plus 4 equals 0. Add 8, add 8, so we get x equals 8. And then subtract 4, divide by 3, divide by 3. So we do have two answers here, and both of them do work with the LCD. But since x is representing her running speed, you cannot have a negative running speed. So our answer is 8 miles per hour. And that's a good place to stop for this section. We will continue it up in a second video.